Hello everyone, I am Sai Karthikeya. In this presentation, we will explain briefly about what we have learned in this internship, and also we will clearly explain about washing machine simulation using PIC16F877A microcontroller. So here the table of content. So firstly we will present about the C programming that have used it to programming an embedded system. It is the basic C programming language that this internship have teached for providing a software to run an embedded system, and it is the mm, important one to run a task in an embedded system. So here the how we will represent the data in C programming. Data representation, we have to represent data of various types like character, integer, short integer, long integer, and the ranges vary depending upon their architecture. Like mm, for different microcontroller architectures have different ranges of the data. For the floating data type, float double is used for the representation of data. So now coming to keywords, to work with the hardware we will use keywords. These are like commanding to the system to do the task in a specific manner. So embedded C allows us to work with hardware devices like sensor and input output devices, and there are totally 32 words keywords in C language. So now coming to the conditional statements. The conditional statements are also known as the decision making statements. We will use this for to implement a task in either ways of to do an task for either one task or different task by using if statements like if ladder switch etc. These statements determine the flow of the program execution. Now coming to string, a string in C programming is a sequence of characters terminated with a null character. The C string is stored as an array of characters. The difference between a character array and C string is that the string is C is terminated with a unique characters. Now coming to operators, the operator is mainly used for computations of values and variables, and these are help us to perform some specific mathematical, conditional and relational, bitwise or logical computations on values and variables. The values and variables used with operators are called operands. So we can say that the operators are the symbols that perform operations on operands. So now coming to arrays. Arrays are the derived data type in C programming language which can store the primitive type of data such as int, character, double, float. It has also capability to store the collection of derived data types such as pointers, structures. In the C programming language, array is very useful for storing the data type. So actually we have to store any data, right? Nextly we are coming to pointers. Pointers in C language is a variable which stores the address of the another variable. Address in the sense, we for every data type we have initiated to this through this C programming must have address, and this address will store as a pointers. The size of pointer depending on their architecture. However, the 32-bit architecture, the size of the pointer is 2 byte. Now coming to functions, a function is a block of code which only runs when it is called. You can pass data known as parameters into a function. So it's a function is a block of code like we will provide the variables to the functions. So it will perform the operation according to their respective function. So we will define the code of the function and use it many times. And the embedded system overview will explain and presented by Madhavi Jureddi.
System overview. What is embedded system? Block diagram for embedded system, categories of embedded system, components, examples and applications of embedded system. Next. Embedded system. Embedded system is a microprocessor based computer hardware system with software that is designed to perform a specific task. It is worked based on real time operation. Coming to the block diagram of embedded system. The main components in block diagram of embedded system is sensors, analog to digital converter, microprocessor, digital to analog converter, and actuator. Sensors are used to take input to the system. It is in analog signal. That analog signals are converted into digital using analog to digital converter, and the signals are processed by the microprocessor, and the digital signal is converted to analog using digital to analog converter, and the output is generated by using the actuator. Next. Components of embedded system: hardware, software, and firmware. And the categories of embedded system. There are four categories of embedded system: standalone embedded system, network embedded system, and real-time embedded system. In real-time embedded system, having hardware real-time and software real-time. And the mobile embedded system. Examples of embedded system: digital watches, washing machines, toys, television, digital phones, laser printer, cameras, automobiles, and medical equipment. Applications of embedded system: home appliances, transportation, healthcare, business sector and offices, defense sector, aerospace, agriculture sector. These are the applications of embedded system. Next. Microprocessor versus microcontroller. Microprocessor is a computer processor with the data processing logic and control is including on a single integrated circuit. And the microprocessor is a small integrated circuit usually composed of central processing unit, memory, parallel input output interfaces, clock generators, and serial communication and analog to digital converters. Next. PIC16F877A microcontroller architecture. It is a PIC microcontroller architecture. Coming to the features of microcontroller architecture. Next. Features of PIC microcontroller. PIC microcontroller is a 8-bit microcontroller known for its RISC architecture. It is a 8 KB of flash program memory, 368 bytes of RAM, and 256 bytes of EEPROM. It operates at a maximum frequency of 20 MHz. It includes 33 input-output pins, 8 channels of 10-bit ADC, and various communication interfaces like USART, SPI, and I2C. PIC, PIC microcontroller having 5 ports: port A, port B, port C, port E, and port E. The device also includes 3 timers. 2 timers 8-bit and one timer is 16-bit and supports both hardware pin and timer interrupts. These are the features of PIC microcontroller. Next. Coming to the peripherals of PIC microcontroller having LCD, LED, timers, and switches. LCD, liquid crystal display. A peripheral LCD can be interfaced with a PIC microcontroller to display information such as text or sensor data. It is used to display the LCD. Next. And the timers. PIC microcontroller having built-in timers modules that are essential for creating delays, counting events, and generating waveforms, including pulse width modulations. These timers are having timer 0, timer 1, and timer 2 are essential programmable registers that increment with each clock cycles and clock pulse. And LED. To interface LEDs with a PIC microcontroller for peripheral display, you will need to configure the microcontroller's input-output pins as outputs. Connect the LEDs to these pins through current limiting resistors and then control the LEDs by writing to the appropriate output resistors in the microcontrollers. These are the peripherals of PIC microcontroller. Next. It will continued by Sai Shankar, project implementation, washing machine code and simulation using PIC microcontroller.
Open project, this PC. As soon as we go, we'll get a .hex file. Then we will open project. Let's select the project. The header files what are required will be here. The source files will be here. We are going to initialize the CLCD, Hitachi one, then digital keypad, then main.h, then timers. The CLCD consists of this kind of in headers. The digital keypad. Here we will initialize the data. When we call here, it can take the code. This is the code for CLCD. These are the required headers for the digital keypad. The programming for the digital keypad where we call the functions. This is the main.h where we call the headers for the main C file. This is the main.c code. We will include the libraries main.h, digital keypad, timers, CLCD. Then only it will take from the given headers. So we will keep the watchdog timer off as soon as it won't reset after the program. So we given all the options, the first step, the second step, and we'll create a loop for the press 5 button. Again, it will come back. Then the power on screen, then the read digital keypad. It will ask for the water level reset. For every one option, we should type the clear screen. Otherwise, it won't go reset mode. We will give a delay of 1000 seconds for every 1000 ms for every button. These are the case statements we used for the switching the timer for different water level modes for high, low, max, minimum. Then we come to the time for the wash, how much wash time, how much rinse time, how much spin time. As soon as we have the LED, depending upon the LED digital lines 16 into 2, we will take the line numbers and we'll give the what digit of line we should print there. Depending upon the calculation, we will give the lines. As depending upon the lines, we will select the code. For every that, we will give the delay of 2000. We will initialize the fan using the timer to on, which is initialized in the headers. Again, we will off the fan whenever it is passed. Whenever it is start, we will go with the fan. This comes for the wash time, spin time. As for the regular time calculations, we will give this. If conditions. We will give the clear scheme. We will give the buzzer on, buzzer off. At the end, door open. If we press the timer to on, it will get off. Buzzer will on. Clear the screen. Clear the screen is like very important for every step. Otherwise, it won't reset. It will just show the previous what we printed. After every loop before it, we should give the clear screen. This is the overall code for the main.c, which includes all the libraries which are required. So this is the option where we can see what microcontroller we selected, PIC16F877A. It consists of checksum, blank, no code. Then it shows the memory, how much we consumed. Out of 38% we consumed. This is the program memory, this is the data memory. Stack we didn't enable. For this, we need to go with subject. So we need to, after every step, we should do the clean and build. So it will save the changes and it will make the build. So we'll press clean and build. It will show clean successful. Then it will show the build successful. With a file, we should get generation of .x and .x both. Now we can open the PIC simulator. So we need to set up this PIC simulator. First, we should go to the file. First, we should select our board. PIC Genesis. Microcontroller PIC16F877A. The clock 20 megahertz. LCD display 16:4. What we are using. Then we can select the code by using the ICSP. So this is the program washing machine. We should go to the dist default production washing machine.x. Open. As soon as we load the code, it will open. Now we will press the switch RB4. So it will show the owning the washing machine. Let's see. Pressing the button, powering on. Now we have a options of daily, heavy, delicates. We need to move it. So we need to press RB3 switch. See, it's moving. Heavy, delicates, whites, stain wash, cottons, woolens, bed sheets, rinse plus dry, dry only, wash only. Let's select wash only. We need to give long press. As soon as the delay time is over, it will get selected and it will shift to the next stage. Now, this is the stage 2 where we need to select the water level. So here we have 4 options: auto, level, medium, max, low, medium, high, max. Let's go with auto. Okay, we'll go with low level of water. We need to press long. After the delay time, then it will take to the next stage. Here we have 2 switches. Switch 5 to proceed to the next step, so it will start. Switch 6 to stop the procedure. Again, it will go to the starting menu. So let's RB4 for starting the program, RB5 for stopping. So it will go to the previous menu. First, let's check the stop. See, it came to starting. So we'll go to delicates this time. Delicates giving long press. We'll go with medium giving long press. So it will go to the next stage. Now we'll press this switch 5 RB4. See, now it start counting 16 seconds. Wash, rinse, spin. The buzzer should be on. If we want someone want to open the door, we can press. So it will show a command: door open, please close. After completing, this will show a exit screen like this. Now we need to switch off. Okay. Let's come with a quick conclusion. The PIC microcontroller F1677A serves a versatile platform for a pyramid of application across industries and domains. If we see a PIC16 using in a CAN microcontroller board, which is used in the EVs like Tesla cars and the Hyundai, where the ADAS plays a main feature, and we can make a man-made rules where we can see the PIC16F877A implementing. So there are many applications of using PIC16F77A in the embedded systems and microcontroller based designs. Thank you.